Warning: always wear proper personal protective equipment when operating Appion products. For ACR technicians, understanding the role of a gas ballast is crucial for effective system evacuation. This video explains what a gas ballast is on an oil-sealed rotary vane vacuum pump and why Appion vacuum pumps are designed without one. To start, let's answer a few questions. What is a gas ballast on an oil-sealed rotary vane vacuum pump, and how does it work? A gas ballast is a valve-controlled mechanism that connects the compression area of the pump mechanism to atmospheric air from outside the pump. The valve mechanism of the gas ballast typically consists of two valves. One is a user-controlled valve, and the other is a one-way valve. When the user-controlled valve is opened and the compression area of the pump mechanism is below atmospheric pressure, the one-way valve allows atmospheric air to enter the pump mechanism. Once the compression area is above atmospheric pressure, the one-way valve will close, and the gas and vapor mixture will continue to be compressed until the chamber reaches a pressure high enough to open the pump mechanism's exhaust valve. In instances where flammable gases or materials have the potential to pass through the pump mechanism, a gas ballast adapter should be fitted to the pump. A gas ballast adapter allows the user to introduce an inert gas, such as nitrogen or argon, rather than atmospheric air, to prevent an explosive mixture from occurring within the pump mechanism. The atmospheric air or inert gas introduced to the compression area by the gas ballast helps prevent vapors, most commonly water vapor, from condensing within the pump mechanism as it is compressed up to atmospheric pressure during the compression cycle. Since most of the vapors are not condensed during the compression cycle, they are easily expelled with the other evacuated gases. Why is a gas ballast needed on an oil-sealed rotary vane pump with a traditional-style oil sump? A gas ballast is essential because the oil cannot be changed quickly or during operation. On pumps with a traditional-style oil sump, the oil surrounds the pump assembly and provides a seal for metal components not sealed with a gasket. This design requires the pump to be turned off to change the oil, further stalling evacuation. Since the oil cannot be changed quickly, a gas ballast is installed on the pump to prevent moisture from being embedded in the oil and to prevent the oil from needing to be changed during the evacuation. This design is acceptable for evacuation outside the ACR industry, where the moisture and contamination content being removed during evacuation is minimal. Why are Appion vacuum pumps designed without a gas ballast? When performing an evacuation on an ACR system, a technician may encounter many scenarios requiring them to be flexible in their approach to each job. These scenarios may include compressor burnouts, water and refrigerant circuit cross-contamination, and high moisture and contaminant content embedded in compressor oils, to name a few. When encountering contaminants in such large quantities, a traditional-style oil sump vacuum pump with a gas ballast is often not enough to keep contaminants out of the oil. Appion vacuum pumps are designed to improve job performance, where these scenarios exist regularly by allowing the technician to change the entire oil sump in less than 5 seconds. Changing the oil sump with fresh oil resets the vapor pressure of the oil to less than 1 micron and removes built-up sludge in the oil sump instantly. This aids technicians in their ability to combat the many scenarios they may encounter in ACR evacuation jobs and keeps the pump working at its maximum capacity for the entirety of the evacuation. Pumps without a gas ballast are also safer for evacuating systems that contain flammable refrigerants, since they are less likely to introduce air to the compression cycle of the vacuum pump that could create a combustible gas mixture. In short, the 5-second oil change system makes it faster and easier to swap out contaminated oil than to run a lengthy gas ballast cycle, negating the need for a gas ballast.